There is a problem with the installation described involving the isolated ground conductor. The isolated ground conductor's purpose is to ground sensitive electronic equipment. Connecting it to the neutral bus bar is incorrect and potentially dangerous. Such a connection could create a ground loop, which introduces noise and other undesirable effects into the equipment's operation. Furthermore, the green screw provided in the mechanical ground bar should be utilized to properly connect the isolated ground conductor to the ground bar. This ensures the isolated ground conductor is correctly grounded, maintaining its intended function. Several sections of the National Electrical Code, or NEC, address this specific situation. NEC Section 250.146d states that isolated ground conductors shall not be connected to equipment grounding conductors, neutral conductors, or to the equipment grounding bus in the panel board or at any other point in the system. This explicitly prohibits the described termination. NEC Section 250.146e provides the correct method for terminating the isolated ground conductor. It states that isolated ground conductors shall be permitted to be connected to the grounding electrode conductor at the service entrance or at the main bonding jumper at the service panel. Therefore, the isolated ground conductor should be connected to the grounding electrode conductor at the service entrance or the main bonding jumper at the service panel, not the neutral bus bar. Connecting the isolated ground conductor to the neutral bus bar defeats its purpose. Isolated grounds are designed to minimize electrical noise from affecting sensitive equipment. Ground loops occur when multiple paths to ground exist, creating circulating currents that introduce noise. Connecting the isolated ground to the neutral, which is already grounded, creates such a loop. A correct termination involves connecting the isolated ground conductor back to the main grounding electrode system. This ensures that the equipment is grounded for safety but avoids the noise associated with ground loops. Using the green screw on the mechanical ground bar to connect the isolated ground is also important. This provides a secure and reliable connection to the grounding system. Using the described method, using the green screw is a proper practice. The isolated ground system is critical for protecting sensitive electronic equipment from electrical noise. By following the NEC guidelines and properly terminating the isolated ground conductor, installations can ensure optimal performance and safety. Remember to always consult the latest edition of the NEC and local electrical codes for specific requirements in the area. The NEC provides detailed instructions and guidelines for safe and effective electrical installations. Failing to adhere to these codes can result in equipment damage, safety hazards, and code violations. When working with electrical systems, prioritize safety and seek guidance from qualified electricians. Firstly, ensure all power is disconnected before working on any electrical components. Secondly, use appropriate personal protective equipment, including safety glasses and insulated gloves. Thirdly, carefully follow the instructions and guidelines provided in the NEC and other relevant standards. Fourthly, double-check all connections to ensure they are secure and properly torqued. Fifthly, test the installation to verify that it is functioning correctly and safely. Sixthly, if any doubt exists about any aspect of the installation, consult with a qualified electrician before proceeding. Improper electrical work can lead to serious consequences, including electrical shock, fire, and equipment damage. Therefore, exercise caution and seek professional assistance when necessary. The function of an isolated ground is to provide a dedicated low-noise path to ground for sensitive electronic equipment. Unlike a standard equipment ground, an isolated ground is not connected to the neutral conductor at the service entrance. This separation minimizes the flow of common mode noise currents through the ground conductor, reducing interference with sensitive equipment. Isolated ground receptacles are typically identified by an orange triangle on their face. They are used in applications where clean power is essential, such as computer rooms, audio recording studios, and medical facilities. The proper installation of isolated ground systems is crucial for ensuring their effectiveness. The isolated ground conductor must be run separately from other grounding conductors and must be connected directly to the grounding electrode system at the service entrance. It must not be connected to any other equipment, grounding conductors, or to the neutral conductor at any point in the system. NEC Section 250 provides comprehensive requirements for grounding and bonding electrical systems. These requirements are designed to ensure the safety of personnel and equipment by providing a low impedance path for fault currents to return to the source. Proper grounding and bonding are essential for preventing electrical shock hazards and minimizing the risk of fire. The grounding electrode system consists of one or more grounding electrodes that are connected to the earth. The grounding electrode system provides a reference point for the electrical system and helps to stabilize the voltage. Common types of grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes. The grounding electrode conductor connects the grounding electrode system to the equipment grounding system. The equipment grounding system consists of all the metal parts of the electrical system that are likely to become energized, such as conduit, enclosures, and equipment frames. The equipment grounding system provides a low impedance path for fault currents to return to the source, allowing the overcurrent protective devices to trip and energize the circuit. Bonding is the process of connecting together all the metal parts of the electrical system to form a continuous electrical path. Bonding reduces the voltage difference between different metal parts, minimizing the risk of electrical shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of conductor that are connected between different metal parts. The main bonding jumper is a conductor that connects the equipment grounding system to the neutral conductor at the service entrance. The main bonding jumper provides a path for neutral currents to return to the source, and it also helps to stabilize the voltage. Proper grounding and bonding are essential for the safe and reliable operation of electrical systems. The National Electrical Code provides detailed requirements for grounding and bonding, and it is important to follow these requirements carefully to ensure the safety of personnel and equipment. If any questions exist about grounding and bonding, consult with a qualified electrician. Electrical safety is a critical aspect of any electrical installation. Proper grounding techniques play a vital role in ensuring safety and preventing electrical hazards. A ground fault occurs when an energized conductor comes into contact with a grounded surface. This can happen if the insulation on a wire is damaged or if a piece of equipment malfunctioned. When a ground fault occurs, a large amount of current flows through the grounding path, which can cause a dangerous electrical shock if someone comes into contact with the energized surface. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect against electrical shock from ground faults. A GFCI monitors the current flowing through the hot and neutral conductors in a circuit. If the current flowing through the hot conductor is different from the current flowing through the neutral conductor, it indicates that some of the current is leaking to ground. When a GFCI detects a ground fault, it quickly trips the circuit, cutting off the power and preventing electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. They are an important safety device that can save lives. Surge protection devices, or SPDs, are devices that are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. When a voltage surge occurs, it can damage sensitive electronic equipment such as computers, televisions, and appliances. SPD work by diverting the surge current to ground, protecting the equipment from damage. SPD are available in a variety of types, including whole house SPD and plug-in SPD. Whole house SPD are installed at the service entrance and protect all of the electrical equipment in the house. Plug-in SPD are plugged into individual outlets and protect the equipment that is plugged into that outlet. Electrical inspections are an important part of ensuring the safety of electrical installations. Electrical inspectors are qualified professionals who inspect electrical systems to ensure that they comply with the National Electrical Code and other applicable standards. Electrical inspections can identify potential hazards such as faulty wiring, overloaded circuits, and improper grounding. By correcting these hazards, electrical inspections can help to prevent electrical shock, fire, and other electrical accidents. It is important to have electrical installations inspected regularly to ensure that they are safe and compliant with the latest codes. Licensed electricians are trained professionals who are qualified to install, repair, and maintain electrical systems. Licensed electricians have completed extensive training and have passed an examination to demonstrate their knowledge of electrical codes and safety practices. Hiring a licensed electrician ensures that the electrical work is done safely and correctly. It is important to only hire licensed electricians for electrical work to protect safety and comply with legal requirements. Working with electricity can be dangerous, and it is important to take precautions to protect against electrical shock, fire, and other electrical hazards. Firstly, always turn off the power before working on any electrical equipment. Secondly, use insulated tools and equipment. Thirdly, never work on electrical equipment in wet conditions. Fourthly, wear appropriate personal protective equipment such as safety glasses and insulated gloves. Fifthly, if uncomfortable or unsure about any electrical work, consult with a qualified electrician. These safety precautions will help to prevent electrical accidents and ensure the safety of everyone involved. Proper grounding and bonding are essential components of a safe and reliable electrical system. Always adhere to the NEC and local electrical codes, and consult with a qualified electrician if there are any questions or concerns.